Hi there. So we're circling back in section 1.7 to do the pre-calc part that I skipped in the trig video. So as you will hopefully remember, in the trig video, all I covered was forming composite functions, objective 3, and writing functions as compositions, objective 5. We skipped over 1, 2, and 4. So let's do those now. All right, finding the domain of a function. If a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. So in simple English, the domain of a function is just the set of numbers that you're allowed to plug into the function, as I like to say, without breaking the function. So some examples of numbers that will cause problems in the domain of your function are numbers that cause division by 0. We always want to leave those out. And real numbers that result in an even root, such as a square root, of a negative number. And those might be the only two that we know about so far. Later on in pre-calc, we will talk about, for example, logarithmic functions. They have a specific domain, and some of the trigonometric functions have domain issues. All right, so for this first example, let's find the domain of the function g of x equals 5x over x squared minus 49. All right, so notice that this function does involve division. So what we need to be on the lookout for with this one is that we don't divide by 0. So here's what we're going to do. Because division by 0 is undefined, we must exclude from the domain the values x that cause the denominator to equal 0. So the denominator is x squared minus 49. So I'm going to set that equal to 0. And this is a quadratic equation, so I'm just going to solve it in the simplest way I can. If I add 49 to both sides, I get x squared equals 49. And now I'll use the square root property that I believe we've talked about before to say that if x squared equals 49, then x must be either the positive or negative square root of 49. Which means that x must be plus or minus 7. Now remember, these are the numbers that have to be excluded from the domain. So you want to be very careful how you write this answer. And if you're doing your homework online, such as on MyLab, it will specify how it wants you to write it. I believe it will want you to write it like this. I'm not 100% sure. Since we're excluding 7 and negative 7, from the domain of G, that means, and this is written in interval notation, the domain of G is the union of the three intervals, negative infinity to negative 7, negative 7 to 7, and 7 to infinity. So this is the whole real number line with just the numbers negative 7 and 7 taken out. Unfortunately, it looks kind of clunky, all right, when you write it using interval notation. Another way you could write it, let me see, is using what's called set builder notation. Now, if we were sitting in a classroom together and you were doing this on paper, I would not be too picky about how you write this, but of course a computer program only understands the answer one way. So another way to write this is using what's called set builder notation. And that looks like this. You say the set of all x such that x is a, real number and x, okay, now I'm going to have to leave a space here. Okay. First of all, I don't want that period. Okay, well, let me leave out the period. Okay. All right. I'm not done writing the answer yet. All right. Now I'm going to put my pen on because I don't know how to type these symbols using what I'm using right now. So I do not want x to equal 7 or, I hope you can see this, -7. So it says, it's supposed to say x is a real number and x does not equal plus or minus 7. All right. That, and I think I forgot to put the closing curly bracket on there. Okay. So that's another way to write it. But I think my math lab, or my lab, I'm trying to get in the habit of calling it by its correct name, my lab and mastering. I'll just call it my lab. I think is going to want you to write it like this, using interval notation. All right, so let's look at the next example. This one I'm going to have to do on the tablet. All right, it's another domain problem. We want to find the domain of the function f of x equals the square root of 24 minus 4x. So it might not be a bad idea to pause the video for just a minute and think about how that'll look. All right, this time we don't have a fraction involved, so it's not that similar to the last problem. Okay, so whenever you're ready, unpause the video and we will compare notes. Let me switch over to my tablet. And let's see. Here we go. All right, so the function is f of x equals the square root of 24 minus 4x. All right, so in order for square root to produce a real number, the radicand, which is the expression under the radical, has to be greater than or equal to 0. In other words, it cannot be negative. It's okay for it to be 0, but it can't be negative. So when I'm finding my domain for this function, the domain is going to consist of all real numbers such that 24 minus 4x is greater than or equal to 0. And now I'll solve that inequality. There's a couple different ways you can do it. I think I'll do it like this. Subtract 24 on both sides. That gives you negative 4x is greater than or equal negative 24. And now I'll divide both sides by negative 4. And of course, when you divide both sides of an inequality by a negative number, you have to reverse the inequality sign, right? So that's going to give me x is less than or equal to 6 on a number line. Well, just put 6 right there. That would be everything to the left of 6, and it's okay to include the 6. So in interval notation, that would look like negative infinity, comma, 6 with a square bracket. All right, so now let's switch back to the presentation. All right, and now we're ready to talk about the algebra of functions. So I had skipped this whole part in the trig class because it really doesn't relate to trig all that much, but it's very important for the college algebra part of pre-calculus. So if f and g are two functions, then we define new functions called the sum, f plus g, the difference, f minus g, the product, f times g, and the quotient, f over g. The domains of those functions are the set of all real numbers common to the domains of f and g. And if you really want to get fancy about it, you can write that like this. So in English, what this is saying is that in order for a number to make it into the domain of one of your new functions, it has to be in the domain of both of the original functions. Remember, the intersection of two sets is all the numbers that they have in common. And that'll come up in at least one example. All right, so here's how you define these functions. Now, this is really a lot deeper than it looks. So for example, the sum f plus g, we're defining how to add functions. So what this is saying is that for each number that is in the domain of both f and g, let's say the number 3, for example, then the function f plus g evaluated at 3 will be equal to f of 3, which is a number, plus g of 3, which is another number. All right, so that's how you define a function. You tell me, what does the function do to each and every number in its domain? Okay, and then the same thing for the difference. The function f minus g evaluated at x is equal to the number f of x minus the number g of x. Same thing for the product. Fg of x is equal to f of x times g of x. Now the quotient is kind of a special case. There is an additional restriction on the domain of the quotient function. Not only does the number have to be in the domain of f and in the domain of g, but additionally, it cannot make g of x equal 0, because then I would be dividing by 0. So the function f over g, evaluated at x, is equal to the number f of x divided by the number g of x, as long as g of x does not equal 0. All right, so now let's look at this example. If f of x is x minus 5 and g of x is x squared minus 1, we want to find each of the following functions. Okay, so we want to find f plus g of x. So those are pretty easy. There's not a whole lot that can go wrong with those. F plus g of x, by definition, is f of x plus g of x. So now I'm going to replace each of those functions with, what it actually is. F of x is x minus 5. G of x is x squared minus 1. And when I simplify that expression, combine the like terms, I end up with x squared plus x minus 6. So that's all there is to it. That's the rule for the function f plus g of x. And then we want to find the domain of that function. So remember, the domain of f plus g, f minus g, or f times g, it's the same thing for all three, is what do the domains of the original functions have in common? So for this one, it's very simple, because the domain of f of x has no restrictions. The domain of f is all real numbers. You can take any number you want and subtract 5. There's never going to be anything that goes wrong with that. And the same thing for g of x. You can take any number you want, square it, and then subtract 1. So the domain of f of x is all real numbers. The domain of g of x is all real numbers. And what do all real numbers and all real numbers have in common? All real numbers. All right. So the domain of this function is all real numbers. All right, the next one is quite a bit fancier, and I'm going to do this one on the tablet. Same thing, if f of x is the square root of x minus 1 and g of x is x minus 5, we want to find the quotient function f over g of x, and then find the domain of that function. So let's switch over to the tablet. And there we go. All right. So f of x was the square root of x minus 1. G of x was x minus 5. Okay. So 3 things have to happen for a number to make it into domain of f over g of x. Number one, that number has to be in the domain of f. All right, so this one's kind of like the one we looked at earlier. It's a little simpler. So we need x minus 1 to be greater than or equal to 0, which means we need x to be greater than or equal to 1. Okay? So the domain of f is the interval from 1 to infinity, including the 1. Now the domain of g, I believe the g in this problem is the same as the f in the last problem, right? In the last problem, f of x was x minus 5. The domain of that function was all real numbers. So this requirement is not going to kick out any numbers, okay? But with the quotient function, f over g, there is one more requirement, and that is that g of x cannot equal 0. And this g of x does equal 0 sometimes, doesn't it? It equals 0 exactly when x equals 5, right? Okay, so we have to kick out x equals 5, okay? So any number that's in the domain of f over g of x has to be all three of these things at the same time. So I am going to turn the page here. I'm going to draw this on a number line to start with, and then we'll write it using interval notation. So x greater than or equal to 1, that looks like this, with the 1 included. But remember, we have to throw out 5. So if I go 2, 3, 4, 5, and now I'll use my eraser to get rid of some of that. We just have to make sure we leave out the number 5. So the way that you would write that using interval notation, you would have to use the union symbol. First, you would take the interval from 1 to 5, including the 1, but not including the 5, and then union that interval with the interval from 5 to infinity. So this interval is there, and this interval is right here. So the domain of the function f over g is this set right here. Okay, like I said, that example is a little on the complicated side, but I can't show you all easy examples, right? All right, so now let's go back to the presentation. If I'm not mistaken, I think that takes care of algebra of functions. Yes, okay. So this part you've already seen in the trigonometry video. I'm going to skip over this, and I'm going to skip over this. You've already seen this. However, we did not talk about domain in trigonometry. So let's come back to that now. Excluding values from the domain of, this is kind of a funny thing here. They probably meant to replace that with an actual circle. All right. Remember the composition of functions f and g. That means f of g of x. Okay, and if you're not sure what I'm talking about, go back and watch the last video. All right, so in order for the composite function to be defined, two things have to happen. Number one, x has to be in the domain of g, and I think that's kind of easy to understand. Remember that g of x usually stands for a number, and so that number has to be defined, right? So we have to make sure x is in the domain of g. And number two, we have to make sure that this number g of x is in the domain of f, all right? Two functions are getting evaluated, right? When you do a composite function, you take a number plug it into function g. So that has to be defined. Then you take the answer to that problem and plug it into function f, and that has to be defined. So two things have to happen. X has to be in the domain of g, and g of x, the number g of x, must be in the domain of f. So let's look at an example of that. Let's see. Here we go. Okay. So in the trigonometry video, you saw this part of this example. Given f of x equals 4 over x plus 2 and g of x equals 1 over x, find f circle g of x. So we've already done that part. Now we want to find the domain of that function. All right, so let's see. Okay, so bear with me here because this whole solution is going to come up all at the same time. I unfortunately cannot, make this come up a little bit at a time, but I'll explain everything. So number one, we have to make sure that any x in the domain of f circle g of x is in the domain of g. All right, so let's think about the domain of g. What numbers are you allowed to plug into this function? Well, you can plug anything in there except for 0, right? 1 over 0 is undefined. So for the domain of g of x, x does not equal 0. And then we have to make sure, I might actually go to the tablet for this. I'm not crazy about the way they're explaining this. We have to make sure that g of x is in the domain of f. All right, so yeah, let's go to the tablet. I was going to do it from this, but I'm not crazy about the way they're explaining this. I think it might be a little difficult to follow. All right, so again, g of x, I'm writing in red now, why not? G of x must be in the domain of f. Okay, so f of x, I'm going to double check this, I think, but I believe f of x was 1 over x plus 2. No, 4 over x plus 2. Okay. 4 over x plus 2. So the only thing that can go wrong with that is that x plus 2 could equal 0. And of course, if x plus 2 equals 0, that means x is negative 2. So we have to make sure that g of x is not negative 2. So the question now is, when is g of x equal to negative 2? Remember, g of x was 1 over x. So now I'll solve this equation by first multiplying x on both sides, which gives me 1 equals negative 2x. And then if I divide both sides by negative 2, I get x equals negative 1/2. So there are two numbers that you have to leave out of the domain of this function. You have to leave out x equals 0. In other words, x cannot equal 0. And you have to leave out negative 1/2. So this reminds me a little bit of the very first domain problem we did in this video, when you just need to leave out two specific numbers. That's another one of those times that you have to use the union symbol. I think I can squeeze the answer in right below this number line. So the first one of those intervals is negative infinity to negative 1/2. And then I'm going to union that with the interval from negative 1/2 to 0. And finally, I'm going to union that with this interval right here, which is, oops, I didn't do that, 0 to infinity. So that is the domain of this composite function. Let's see. Oh, what is going on here? There we go. I just want to bring the, lost my window. There we go. Okay. Yeah, so that's the same answer we got. And I just want to point out that that answer makes sense. You can see here why the -1/2 has to be excluded, because after you simplify the answer that we got in the trig video, remember that was this one, -1/2 would make that denominator 0, okay? Now, it might not be quite as clear, why do you have to also leave out x equals 0? And that's because the actual function is this one here. All right. So you can see why you can't plug 0 into that function. It gets lost when you simplify it by multiplying the top and the bottom by x. So if you want to be super technical about it, the composite function f circle g is 4x over 1 plus 2x with the added restriction that x cannot equal 0. These restrictions are pretty important when you get to calculus, so I don't want to just ignore them. All right, and that is finally everything you need to know about 1.7, so we'll see you next time.